guys, welcome back to John's Workshop, and in this video we're going to be going back to the make of the Flame Licker engine by Jan Ridders, the engine Marc, and in this particular video we're going to be focusing on the tumblers, the valve tumblers as they're called, or valve levers as I would probably call them. So as you can see on the board behind me, they're all brass construction. So originally I was going to make these from solid, but I'll walk you through my thinking on that in a minute as we go and have a look on the screen at what we're actually going to make. There's some tiny holes, 1mm diameter holes, so that's going to be interesting. Work holding on these, because of the shape of them, is not going to be easy, so that's going to need a bit of careful consideration in terms of the order of operations and things like that, so that we can still hold the material effectively. And also, because I'm now not going to be making them out of solid, there's an opportunity for me to practice some of my soldering techniques and have a play with the baker's fluid that I've now got. So that's all interesting. So without further ado, I will join you in a minute at the command and control centre, and we will have a look at the bits that we're going to be making. Okay guys, we're up at the screen. So the bits we're going to be focusing on in this video are these brass valve tumblers here. So there's two of these, one each side of the main base bridge, if you want to call it that. They're linked together via a rod, and they both drive or hold the valve springs, so they both hold the valve springs in position and also drive the valve up and down. And on the lever on the far side, which we'll just try and zoom in on so you can see that more clearly in this picture. So you can see the end of the lever there, so we're looking end on now, and you can see the cam on the crankshaft, and the cam follower, which sits on top of that cam, is joined to this lever on this side. So this cam follower lifts both of these tumblers up and down, and then through that motion is transferred through the springs up onto the valve plate and open and closes the port on the side of the cylinder. So if I go back to the other view where you can see these a bit more clearly in a sort of 3D view, you can see we've largely got a piece of flat plate in the middle, tapering down from a larger diameter to a smaller diameter, and we've got two spigots, one on each end, one to hold the valve spring and the other one to location onto the shaft to join the two things together. So originally, when I was ordering the materials that I needed for this engine, I bought myself a big healthy slug of brass, which is this. That's about ½ an inch thick, I think, or it might even be a bit thicker than that. So sort of 15mm thick by 30mm wide, I think, something like that, by probably 200mm long. So originally my plans was I was going to machine both of those out of one short section of this by splitting it up the middle, and and getting two out, and actually milling these out from solid, which, the more I've looked at it, that's an awful waste of brass really. Whilst it would have been an interesting setup, it's quite a waste of brass. So what I've done is had a dig around in my offcuts bin, and I do have this piece of brass here which is the same width. It's 3mm thick, and I will be able to get two side by side out of one length of this. So I need a length about 75mm long, slice it up the middle, I can get two out of that. That makes these two end pieces, and then I've got some small brass bar that I can turn the diameter pieces, the 4 diameter pieces that I need for each end, and then we're going to solder those in place, and then we're going to make everything good at the end of the day. So first job of the first order of the day is cut myself a length of this off that I need, and then we need to get this down from 3mm down to 2mm thick, which I'll be doing on the milling machine. So I'll join you on the milling machine just shortly when we get cracking with the first pieces. Right, I've chopped my piece of brass off, and I'm going to go for something a little bit unconventional here. So two things. This vise, one, is not very good at gripping on the top millimetre of jaw. For whatever reason, I think what happens is the bottom of the vise closes in further, causing a wedge shape, which means the very top millimetre of this is liable to let go. So one, I don't want to be gripping this on a millimetre of stock to try and get this down from 3mm to 2mm. That's the first thing. And secondly, I have a feeling that if I just machined all the stock off one face, because of the process that's gone on to make this brass, the rolling process that's gone on to get it to this size, I think there will be residual stresses in there, and if I take the skin off, all off one side, I think this will bend like a banana. So what I'm going to do is stand it up in the vise like this in two halves. I don't know whether this is going to work. I think this might be a bit ringy, but we'll give it a try. Got a nice sharp carbide end mill. We're going to try and take 20 thou off each side, get this down to 2mm, switch it round the other way up, hold on what I've just machined and do the same the other side. Bearing in mind I've got two parts to come out of this and they're going to be split down the centre line, so I don't really need this to match up, I just need both sides of this to be 2mm. So we're going to give that a go, and largely if I wanted to machine conventionally holding on the top millimetre of the vise with this laid flat, I would have to machine the two edges first to grip it, because these are just as formed edges, so that would be two more kind of operations, if you want to call it that. So let's see how we get on. So guys, we're just about to set up on the lathe for the two diameter pieces that I need to go at each end of the tumbler arms. One end is 8mm and the other end is 12mm. So I bought some brass stock that I've shown, I think, in my recent blether video, which is about 20mm OD, and that was my original plan, was to turn these out of that, but I thought I'll just have a bit of a dig round and just see what I have got. So I've got this lump of brass here that's all bent and twisted. It's had a thread put on one end of it at some time, but that's actually 9.27, so very close to the 8mm, so we'll get the 8mm ones out of that. And then for the 12mm ones, I found this tiny bit of brass, which again is 13.45, so minimal waste using these two bits. So we'll set up now, we'll do the 8mm ones first, I think, and then we'll move on and do the 12mm ones. There we go, reasonably successful. So that's our two 8mm pieces done. I'll set up and do the 12mm pieces now. They're very similar, so I'll not film that. The only difference is, rather than having an M3 thread through the middle, they've got a reamed M4 hole through the middle, but apart from that, absolutely identical to what you've just seen. So I'll bring you back when I've done that. Right then guys, we're going to have a bit of a play with this baker's fluid, and I've found my resin cord solder from probably the early 1980s, I would think. We've given an acid brush a bit of a haircut to get me down to a fine point, because that's all I've got at the minute. I'm going to get myself a couple of small brushes if this is successful, and I'm going to use a cap screw just on top of the small diameter piece here, not to hold it down tight, but to hold it down enough to stop it moving around under the force of the flame, because this is so small I think this will probably move around. So just to add a little bit of weight, we're going to give that a go and see what happens. So the first thing I need to do is get some of this baker's fluid onto the part. So I'm just going to dip the brush in. It's really interesting, it's just sitting on the surface. Like I say, I've never used this stuff before, so we're on a learning curve here guys. I'm going to drop our piece on top. I'm going to move it to the right place, roughly. Drop our cap screw on top to hold it, and put my brush out of harm's way where it's not going to hurt anything, and then we'll see what happens. I'll zoom you in. I'll bring you back in a minute. It looks like it's gone okay. Right then guys, we're going to do the big end now. So what we've done is used our vernier, an old vernier. I know exactly what my diameter should be, or my distance should be across the OD of these two things. So we've set that correctly with the vernier, and we're using a slightly heavier weight to hold this in place. So I think that's going to be pretty close, or at least I hope that's going to be pretty close. We'll give it a try. I guess worst case scenario, we can always unsolder it and have another go. Let's see what happens. Learning all the time. I'll let that cool down, we'll give it a wipe off, and we'll give it a measure and see what we did. Exciting times. Right then guys, we've had some real success, and we've had a bit of a clown moment. So the real success is we've got both of those soldered on with minimal cleanup to do, minimal amount of solder on, so much more controllable than what I did on the fuel tank. Bit of a learning curve, is a little bit too much. I should have flicked that off with a brush on that one, but I did that on the second one, and it is now just a very thin, very thin layer, and most of that's getting machined off at that end anyway. So how did we do? So now I've cleaned all the bakers off, I've brought my big vernier back in. Let me just zoom you out a little bit so I can get everything on the camera. So we should be 73mm over these two, over the OD of these two diameters here. And I've got .93, 72.9293, something like that. So we're within 3 thou. For a soldering job, I'm pretty pleased with that. This way we should be 10mm if everything's worked out okay. We're 10.03, and on this end we should be, and I've got a bit of a burr I need to negotiate there around the bore that I need to clean up, but we should be 5mm, and we're measuring 4.99. So for a solder job like that, I'm pretty pleased with that. That's saved a lot of material hogging out, so that's all the good stuff. The clown moment was, as I told you all earlier, I was going to drill and tap a hole in the end of this boss before I soldered it on, and I've completely forgotten to do that. So not to worry, we're going to make both of them equally wrong, so I'll make the other one the same, and then we will deal with that at a later date when we're finishing these off. But yeah, I'm really chuffed with how that's gone. It looks really simple, I know, but to get those kind of dimensions, balancing screws on top of things and soldering on a bit of breeze block that I had left over from filling the window in, I'm chuffed to bits with that. I'll get the other one done the same, and then I'll bring you back when we're looking at cleaning these things up and finishing them off. Happy days. So guys, the plan here was always kind of something like this in my mind. So I've got a ground block sat in here that's trapping the 2mm piece of brass plate to the fixed jaw. I've got that sat on a couple of parallels just to make setting it up easy. I've got my lever clock in, and basically the plan, and I've just got this just lightly nipped, and the plan here, hopefully, if this works, was to be, that's probably a bit too hard. The idea was going to be, and I don't know how easy this is going to be, we'll find out shortly. To just run the lever clock over these two diameter pieces. So that one's not moved, that's just over 5. This end is, there's my high point. There we go. That's on 10. And that's on 10. Right, we're ready to machine this now. So what I didn't say when I was setting this up was the machining I'm doing here is to make the sides of this lever arm tangential, is the correct word, to the outside diameter of both of these radiuses. Now there's different ways I could do that. I could set this up in a planer, you know, at 90 degrees, and I could calculate the angle off the drawing through trigonometry, and I could set it at the right angle and do it that way, and there's some maths involved in that, but I thought I'd show it this way because this takes all the maths out of it. this is dead simple. By doing the way I've done it, by clocking the top of both of those bosses there and levelling it up, there's no need for trig, there's no need for calculations. As I machine this down now, it can be nothing other than tangential to both of those two bosses. So we'll give it a shot and see how it performs. So we're over at the vise, and hopefully now a lot of my previous projects are all starting to come together and make sense. So I've got my nice soft jaws that I made in the vise. So before we start, we're going to clean those, make sure there's nothing ugly in there from what I might have been doing last time that is going to mark the part when I start gripping it. And we'll set about the first one of these. Just going to hold it in the vise, not too tightly, but tightly enough to resist any movement when I'm filing. And we're going to start with quite a coarse file and see how we get on. Right then guys, there we go. That's got our two levers done. They've had a draw file. They've had some coarse wet and dry just around the profiles, still to have the 1200 grit. Try again. Still to have the 1200 grit wet and dry treatment as a final cleanup before we give it a final polish at final assembly. Lots of finals in that sentence. So next job now, we need to load this up back onto the mill, and we need to pop the two holes through the brass plate to continue those on. Then we've got, as I said earlier, we've got a cross hole 1mm to drill through here, and we've got, due to my cock up, an M3 hole we need to drill in this end, which I should have done earlier and forgot, and drill and tap that for a grub screw to lock this lever onto the shaft that drives it. So I'll bring you back on the mill just shortly, but I'm pleased with them. Alright guys, we've got our fixture plate set back up in the vise again. I've got a solid carbide end mill that's got a 4mm ground shank on it. So we're just going to drop that in the chuck. We'll just eyeball that. I'd eyeballed it roughly, but just eyeball that over that hole, make sure we're clear. There's a hole in the plate there, which is good. We'll use that. Got my clamp somewhere near set up. So what we're going to do now is bring this down until we're locating that 4mm reamed hole on the part. That's fine. We'll just nip that up with an Allen key. So we're now set up over that hole. We'll get my drill, we'll drill through, and then we've got our 4mm reamer, and we'll continue that reamed hole through. Right then guys, I've tried to pick a setup now that's going to do me for both my cross hole this way and my threaded hole that I've got to do in the back of this. So little angle plate in the vise on a set of parallels. Didn't have to be on parallels, I could have stuck it in the bottom of the vise I guess, but they were already in the vise anyway. So, and what I know is the difference in diameter between the boss at one end and the boss at the other is 4mm, which means radially that's 2mm. So this is really Mark 1 eyeball. I've basically lined the big boss up flush with the top of the angle plate, and I've eye-sighted a 2mm drop from the top of the angle plate to the top of the boss at this end, and that's going to be more than close enough for what we're doing here. So we've now got a 1mm hole, which is going to be a giggle and a half to drill through here. So I'll get myself set up and bring you back when we're having a go at that. Right guys, we're just setting up to put the M3 hole in the top of this diameter piece here now. So that's what I said earlier, I tried to find a setup that would do both the small hole and this one, so this is ideal. So what I'm doing again, this is Mark 1 eyeball again. Two ways of checking this, and I'm using both. So I've got my little square and I'm just coming in, touching the top diameter, and I'm looking for my 2mm gap roughly at the bottom, which is about what I've got there, and also putting it up across the front, and I'm just eye-sighting straight down the centre line of those two holes. It's not important, but I want to get it as near to centre as possible. So that's us set up at that, so I'll bring you back when we're putting the hole in. So I thought it was worth showing, it's a bit of an old toolmaker's trick. I'm not setting this up with an edge finder, so I'm just going to use my rule, very similar to what you do on a centre lathe, to find when I'm over the centre. So I can see I'm too far forward there. Just going to keep bringing that down, and I can line this up nicely with the top of the angle plate with the 6-inch rule. Tiny bit more. There we go. Spot on, just as well, being as I dropped the rule. So I now know I'm over the centre. Alright then guys, another lash up. So I've got a ground block that was sat on some parallels that I've now removed, so we know that's sat square in the vise. I've got my lever, my tumbler, clamped to that with the toolmaker's clamp. I was incredibly lucky that a stack of parallels that I found just was a nice, and I mean a really nice, sliding fit under there on the top of the vise to give that some support. So I've got my wobble bar in with a pointer in it. I've marked my part out where the hole needs to be, so we're going to true this up, get over my centre point, and then we're going to spot drill and ream 4mm. there we go guys, that's got our 2 valve tumblers made, and I've really quite enjoyed those. As with all of this engine, as I've said, there's lots of firsts for me. So that's the first time I've ever drilled, to the best of my knowledge, a 1mm hole. It's the first time I've used baker's fluid for soldering, and it's the first time I've ever made parts this small, if I'm honest. You know, turning, boring and parting off 3mm slivers of brass and things like that. So lots of new stuff. First time I've machined brass, thin brass, by flank milling to get it down to thickness, which is how we started this project off, out of the stock. So yeah, lots of different things there and lots of different setups. So that was quite, you know, despite how simple these actually look, quite an involved component. And you know, the way I've gone about it isn't probably the quickest way or the best way. It's the way that I've utilised the materials that I'd got, and also the tooling that I know I'd got, to get me to a decent result. Now, the other way I could have done this was how I'd originally planned, which was mill them out of this big chunk of brass and mill them from solid using a rotary table and keeping everything really accurate and all the rest of it. But as I've shown with this, with the soldering, you know, my worst error away from drawing on any of the positional stuff that really matters on these is about 3 thou or 0.07. So considering what these are, I'm more than happy that that's accurate enough for what these are doing. So, and incidentally, between the 2 diameters, if you look at the 2, I know you can't see from there, but between the 2 bores that matter, if you like, at each end, they're within 10 microns of each other. So really pleased how they've turned out. I hope you found some of those setups interesting, useful, different, might have given somebody some ideas who's making something similar. So with all of that being said, thank you all very much for watching. Hope you've enjoyed that. Thank you for subscribing, and thanks to the new subscribers who are coming along, and we will catch you all very soon on another video when we'll be making something else.